Okay, so why do we factor? Up until now, if I gave you a problem like, and I asked you to factor it, there really isn't any purpose to factor it unless you are trying to solve an equation. So usually you need to get that equal to 0. The reason why we factor is so that when we have quadratics, which is what we are dealing with, x squared is a quadratic term. Let's see. So x squared is a quadratic term. This has an understood 1. It is the linear term. And this actually has an exponent of an understood x to the 0 power. So this is called the constant. The degree of the term has to do with how many solutions you would end up possibly having. So if this is a quadratic term, that means we could have 2 solutions. So that means that your parabola, this is what this is called, your parabola could intersect the x-axis in 2 spots. So our purpose is to find the zeros. So our purpose is to find the zeros. Sometimes we call those find the x-intercepts. I think sometimes it's called find the roots. Okay, so if I have an x cubed plus something else, I'm just making this up. Okay, so if we have a cubed, that puts one more hump or one more dip in your graph. So that means that we could have 1, 2, 3 times. It's not saying that we will, but we could. So we would be looking for that value, and that value. Okay? When we're dealing with a quadratic, like I said, you can either have 2 solutions. So you could have 2 where your parabola crosses here and here. So this would be 2 solutions. You could have 1 solution, so where your parabola just touches your x-axis. So that would be 1 solution. Or we could have it where the parabola doesn't touch it. So this would be no solutions. And we'll talk more about those when we get into the graphing of quadratics. But this is why we solve by factoring. Okay, so if I give you p squared plus 14p plus 48. A lot of times I have taught it by doing the product sum table, where your product is your A times your C and your sum is B. We did a worksheet recently where it was drawn like this. This is still your A times your C, and now your sum is down there instead. So A is 1 times my C, which is 48. 1 times 48 gives me 48. So that is my product, and my sum is the 14. Watch that sign, because if that's a subtraction sign, then your sum is going to be a negative number. So 14. So those are the 2 numbers that I'm looking for. And off the top of my head, I know that 8 and 6 will work. 8 times 6 does give me 48, and 8 plus 6 does give me 14. Because this is has an A of 1, I know that this is going to factor into 2 binomials. There's my magic numbers. What gives you p squared? It is p and a p. My 2 magic numbers are a positive 8 and a positive 6. And like I said, usually the reason why we do this, actually there's no other reason, but the reason why we do this is to solve an equation. So usually it would start off with being an equation. In order to find out what values this would have to be, you're going to set each factor. Here's one factor and here's another factor. You're going to set each factor equal to 0 and then solve it. So p plus 8 is going to equal 0, and p plus 6 is going to equal 0. So then you solve. I need to subtract 8 on both sides, or excuse me, 8 on both sides. So p would equal a negative 8, and here I'd have to subtract 6 on both sides. So p equals a negative 6. The reason why this works is if I put a negative 8 in here, what is negative 8 plus 8? It is 0. So 0 times anything is going to equal 0. That's what we want. If I put a negative 6 in for this one, negative 6 plus 6, this is going to give me a 0. So 0 times anything is going to be 0. So p equals negative 6 and p equals negative 8 are my solutions. So that means in the whole scheme of things, I'm not going to talk about opening up or down, but my parabola would cross at negative 8 and would cross at negative 6 as well. Okay, and so we will talk on how to determine whether or not it opens up or whether or not it opens down. We will talk about that more when we get into the quadratic unit. Okay, let's do another one of those. Actually, I'm going to give you an equation that is already factored. Okay, so this is what you want. This is already factored. So we are at the step where we are going to set each factor equal to 0. So 5m plus 1 should equal 0. And I need 3m minus 5 to equal 0. This goes way back. You are just solving an equation. Get rid of this guy first. So this is adding 1, so we are going to subtract 1. So 5m equals a negative 1. Need to get rid of the 5. It is multiplying, so I need to divide both sides by 5. So m equals negative 1/5. Back over here, I'm going to add 5 to both sides. So 3m equals 5. Divide both sides by 3. So m would equal 5/3. So negative 1/5 and 5/3 are my solutions. So that means that my parabola would cross at negative 1/5 on the x-axis, and it would cross at 5/3 or 1 2/3 on the x-axis. Last one I want to cover is what are you going to do if you have a variable in front of well, that just means that we don't just have two terms or two factors. We have 1, 2, 3 factors. So we are going to set each factor equal to 0. And solve. X equals 0. This is already done for us. Add 4 to both sides. So x equals a positive 4. Subtract 3. Divide by 2. So x equals negative 3. Whoopsie, sorry. Negative 3 halves. So there I have a possibility of 3 solutions, and that is because if I were to distribute and then distribute again, I'm going to have a cubic term. I'm going to have an x to the third. In Algebra 1-2, we're focusing on quadratics. When you get into Algebra 3, 4, that's when we'll start moving more into different exponents. So the whole reason why we factor is so that we can solve these little itty-bitty linear equations so that we can find our solutions of 0, 4, -1.5. So my graph may look like that. Okay, that is why we factor.